it's basically over. I completed everything and started contributing. I was spending more time on contributing to another project, the SHF, because just because they were having regular meetings, so it was easier to follow what they're focusing on.
Yeah. All right. Now we are definitely live. I can see the live stream also on YouTube, so recording should be all fine. Okay, as I just mentioned, we're planning to give a tutorial on how to work with rspec, and especially how to develop in the backend if the front-end part is not yet ready. So there are a couple of tasks that need to be done, and they both affect front-end and backend. And in order not to block people in the backend, we want to create some rspec tests, and those rspec tests will be the substitute for the front end. And the front end will then later implement this interface. And my idea was to explain how to create an rspec test for this item-to-item similarity matrix. I will just, so first of all, welcome Matt again. He's attending this Scrum right now. I will now start screen sharing. So people can see what I'm doing. So my idea was that explaining what has to be done regarding this visualization here, right? So this is a missing feature, and as far as I know, Thomas wanted to work on the relationship between broadcasts, right? So we see a graph in this picture, and the nodes here are representing broadcasts, and the edges between the nodes are representing relationships. Okay? Does it make sense, Matt?
Yes, it makes sense. What are the relationships represented as?
That's a very good question. The relationships are based on how often two broadcasts were selected by the same user. So a user can support a broadcast, and a user can support another broadcast. And if you do so, those two broadcasts will have a similarity. If many people support the same broadcasts, those broadcasts will have a higher similarity. Does that make sense?
Could you repeat that last part again?
The similarity is based on how often are two broadcasts supported at the same time.
So you said by a single user supporting two broadcasts?
Yes,
okay.
Exactly. It's basically, this whole technique is called collaborative filtering, and it's the same that Amazon is doing for products. So when you can see other, people have, if you buy an item, then you can see other users have bought this and that item, for example, right? Because these items are similar to each other. You can use these similarities for recommendations. Okay?
Are the users linked to each other somehow? So like are users clustered together too, or just items based on, like, do they say these two users are similar and cluster the items that they have in common together?
So you can basically do both. You can either cluster users, but you can also cluster items. It depends on your use case. And in our use case, we are interested not on users, but on items, that is broadcasts, right?
Right.
So, yeah. That's based so far. And and our use cases, we don't want to give recommendations. That's not so interesting to us. We just we are interested into the similarities themselves. We want to have this graph in the end, right? So all of our 419 broadcasts will be represented as nodes, and those broadcasts that are selected by the same users will be connected to each other. Does that make sense? That's the result that we have, the goal, the ultimate goal of this feature. Is it clear?
I have a question.
Yeah.
So, I mean, would you be recommending, right? This is like a recommendation type system, correct?
Yeah, it is commonly used. This technique is used for recommendations.
So is that your application, like your goal?
No, we don't want to use. We don't want to have recommendations. We just want to have similarities. So in other applications, you can use those similarities for recommendations, right? One user bought this item, and then you can show him other items that are very similar to this item. That's what this would be the recommendation. Mm-hmm. But in our case, we are more interested into the similarities themselves. So we want to have an interactive graph. So I imagine that you, for example, can click on a broadcast, like one of the nodes, and then you see all broadcasts that are similar to this one, right? This could be of value for the broadcasting corporations. So, is it clear? I'm not quite sure if this makes sense.
I'm just asking about like the objective. So basically, someone selects a broadcast, and then you display similar broadcasts to that broadcast.
Yeah,
basically the objective is similar broadcast. Like the use case, the user goes to your website and they say, "I like this broadcast," and you say, "Well, you may also like these other ones." I mean, that's telling you you're not doing a recommendation system, but I mean that's kind of
we could give recommendations, although this would bias people probably, right? And this is we are not interested in biasing people, let's say. I don't know. Maybe we'll give recommendations in the end, but first of all, we just want to have the similarity. Having the recommendation is as the next step, I would say. Mm-hmm. The similarities themselves are of value and they're interesting enough. Okay. Mm-hmm. So I'm now searching for collaborative filtering. So this is how I would start with this feature, collaborative filtering and item to item, maybe. And what we then see is then, okay, we get a Wikipedia article. That's great. It explains the whole concept from the from the history and also from the theoretical background. What we are interested in is more or less a tutorial. That's why I also type in tutorial. And I already found this nice tutorial which explains what you have to do. So can you see this more or less?
Yes.
Great. So the use case here, and we have to adapt this for our use cases. You have a long table and you have a user column and a column with all the items and a rating. In this case, you have numbers. In our case, we just have 1 or 0 because either user is supporting this broadcast or the user is not supporting this broadcast. We could also give the amount here, right? You can give virtual amounts to broadcasts, like €1 or €2. We could use that too. But I think to keep things easy, let's just assume the user is either supporting it or not. Does that make sense?
Yes. It's
cool.
It's like a sentiment analysis.
Yeah. So the rest of the tutorial is more or less some mathematical background. I will not go much into detail. I will just explain the results of the stats. So here we just have the same table listed as a matrix. And then you can apply a certain mathematical function, which is called cosine similarity. I would say it's too complicated for now, but let's say that it is just a very basic way of comparing vectors. And that's the reason why we have this matrix here, because then we have vectors for every user. And all in the end, we will have this result here, right? So M is an item, okay?
Okay.
And we have for every item the similarity to all the other items, right? One item is 100% similar to itself. That's why we have 1 in the diagonal here. Does that make sense?
Yes, it does.
And these numbers here, these numbers are the results of this computation, which is explained above, like this one here. Okay?
Okay. So that's basically just like something like correlations between.
Yeah, it is actually something like correlation. This
correlations
thing. So all we need to know in order to have our rspec test is to have this. Assume that we have this table here, right? I mean, this is we will have some kind of background job that is doing all the computations on all broadcasts. And in the end, we will have a big table with all the similarities between broadcasts. No?
Yes, that makes sense to me. It's
Yeah.
a little bit mathematically complex, but I mean, basically there's a good value between 0 and 1. 1 is the total 100% match, and 0 is no match, or no similarity. 1 is 100% similarity. I think that's the general idea, right?
Yeah. So, yes, so exactly, yes. Now I would start with the actual coding, and that's why I'll start my screen sharing again, but this time with my terminal, maybe? Can you see my terminal? Good enough.
Yes, yes, it's a little bit small, but I can see it.
Font size is good.
Characters.
Okay. Great. So I will just switch into this for our project and open my editor. Takes a while. So just to give 2 directions, we have some kind of background job, right? And we want to have, in the end, a table with the similarities between 2 broadcasts, right? And I would just do that. There's a job here. We already have jobs in our application, which is so jobs in a Rails application are background jobs that can run anytime, can take, are usually doing some kind of long processing stuff and can, like, for example, send an email to 1,000 users. And in our case, this background job would, for example, create all the similarities between all broadcasts and do all the computational stuff, right?
Yes.
So I would start to have this kind of job. I can show you one job, which is a geocoding user. So you have one user. This is just an example, right? I just want to show you how a job looks like.
So this is inside the Rails API for jobs.
Yeah, kind of. There's a Rails API for jobs, and in our case, we're using Sidekick for processing jobs. And this is how a job can look like. So you have a class descending from application job, and it has a method called perform. Here you have those parameters that will be given for one job. in our case, the user ID in order to identify the user. Okay?
Okay.
And we are now creating another job. For example, I will generate it. There's a generator for it. You can still see my terminal, right?
Yes, I can see your terminal.
Good, because I'm not quite sure. I'm using i3. I'm not quite sure what Jitsi is actually showing. So here you can, for example, see, okay, there's a generator for a job. Why not let's just use it? Okay. So I say bin Rails generate job. How shall we call it? Create index or something, or compute similarities? What is your Matt?
Yeah, it's something like compute similarities.
Right.
That sounds good.
Compute similarities. There we go. And then we see there was there's a test already created for us, and the job itself.
I can't actually see you. Were you typing a generator type function thing in or something, or?
I'm typing in bin Rails G for generate.
But I can't.
Can you see it?
No, I can see your screen, but I can't see you typing things in.
Oh no. Oh yeah. Yes. Yeah. It's already. It's just showing my.
It's just showing the geocode user job Ruby.
Yeah. So I just generated a job, and it turned out to like it turned up here. I just typed in bin Rails G job, and then I give it the name, and then we have this class here.
Okay.
Right. So since we are not, we don't need any ID or something. We are always computing the similarities for all broadcasts, I would say. Right?
Yes.
So that's why we don't have any arguments here. And this is pretty much it. For the test, I'm not interested into the actual implementation. I'm more interested into the test. So I'm expecting that when this job is run, we will have some kind of a big table with all the similarities, and that's why I'm opening up the spec now, right?
So what will the input be and what will the output be?
Yeah, so the input is the table of all the list of all broadcasts and the list of all selections, that is, or the list of all votes. I think we agreed on using the term vote. No?
I don't remember, but it sounds fine to me.
Yeah. So we are describing this job, and we are describing the method perform, right? That was the method that was just generated for us. And now we need some kind of input, right? Or, well, let's start with the job without any input. What do you guess? What is our expectation if we have two empty tables, no broadcasts, no votes? What should be the output of the job?
An empty table?
Yes. It returns, or its form results in empty table, in empty similarities, because similarities, that's what we are trying to create, right?
Yep. So empty similarities table.
Yes. So I'll just say for example, subject expect object not to change similarity count. So what I'm doing here is subject. I'm expecting that subject is compute similarities job perform, which I'm writing here. For example, say described class form, or
the screen's frozen.
Screen is frozen. Oh no. Just tell me when, as soon as you see something.
Yeah, it's just showing the geocode user Ruby, and it's frozen on that. Nothing's changing.
Better?
Yeah, it's much better.
Right. So this is the test for this job for now. I'm just saying, okay, we have a job. The job is just a new compute similarities job. And then we say the subject is job perform. Our first test case is that if we run subject, we're not expecting to increase the number of similarities, which should be 0, right?
Right.
Okay. But context, given 2 broadcasts, and now we are create a list of 2 broadcasts, right? And context given a user supporting both. And now we have to think, okay, so we need a user maybe. You're familiar with the lets in rspec?
Could you explain that?
Yeah, so let, you can Google for betterspec.org, which is a list of best practices for rspec. Very, very valuable.
Okay.
I'll provide the link. Betterspec. There we go. I just put that into the Slack.
I think that's basically like a double of creates a. That's how it does.
Yes, it's just a method. It's lazy initializing a user object. And then we say, okay, this user created, has voted on both broadcasts, right? So we create a selection with this user, and first broadcast, and the response was positive, right? You still see it, what I'm doing?
Yes, yeah, I can see that.
And we're creating another selection, this time with the last broadcasts. Okay?
Okay.
So what are you now expecting what should happen? Like, what do you think what should be our result?
So they would have you create a table with 2 entries in it, and there would be a 100% match. It'd be a 2x2 table with all 1s in it.
Yeah, exactly. So we want those 2 broadcasts to be similar to each other because there's a user that has supported both. No? So
Yes.
now we are expecting subject to change similarity count from 0 to 1. For example, this is a very, very generic expectation. I mean, we could expect that the similarity is exactly between those two broadcasts, right? We're just expecting, okay, there's a similarity now. End of this, end of story. It might be better to specify exactly what the similarity is between. No?
Yeah.
Yeah. I think it is, for this particular test case, it is okay to leave it just like that, because there are only two broadcasts, and if we have a similarity, we can just safely assume, okay, it must be those.
Yeah, I think that's fine. You just want to make sure that when there's two tests, that when there's two positives, I mean, when the two responses are similar, then you get a high similarity score. When they're
exactly,
similar,
exactly. Later on, you would then expect a certain score on the similarity.
Right.
Like some further down, you, for example, could then, I don't know. Oh, maybe you could then describe score of similarity. Subject is now similarity score. How about that? And we have to define, okay, what is actually similarity? And similarity could be similarity, the first record in the table. Okay. And we don't, we of course, because subject has changed now, we need to run the perform method of the job. So we say before job perform, because if we are calling subject, this method above here, this will be executed. If we change the subject and we want to have the job to be performed, we have to do it manually. That makes sense?
Yes.
And yeah, so the score of similarity should, for example, I don't know, it is expected to equal 1. I'm not sure, right? I don't know what the similarity should be like in this particular test case scenario, and that has to be, yeah. Probably you have to look into the actual algorithm in order to find out, which I'm not going to do.
Did you just stub some values? Or,
yeah, I'm just expecting a 1.0. Fair enough. Right?
Right.
Okay. So I think for explaining how to start with the rspec test is quite enough. Let's just run it. So I am opening a terminal, and I say bin rspec, and I can also explicitly. Oh, I should change in the backend folder, and I could say, for example, spec jobs similarities, and let's see what happens. Takes a while. But is it clear so far? Matt, give me some feedback.
Yeah, I mean, it's somewhat clear. If you went through and described each line was doing, it'd be really clear. But I mean, I basically get to what's going on.
Oh yeah. So I can see already one error here. I mistyped factory. It's of course it's not broadcast. It's just singular broadcast. And we don't have the similarity model, which is the join model between two broadcasts or broadcasts in general. Is that clear?
Yes. So similarity model has not been created yet, so we're getting a bunch of errors.
Exactly. And now what we can do is, whoops, where am I? Yeah. Oh no, wrong one. So I'm just correcting my typo, which is up there. So cast. So this is all we can do for now. And whoever is going to implement this needs to provide the similarity model, right?
Right.
And I mean, this is how you would then go ahead with the implementation. And the very specific thing here is that the similarity model is a so-called bidirectional join model. So it's joining not two distinguished tables. It's joining the same table, right? Usually you have two tables, like users and products, or users and posts.
You have one table. Is there another table for the joins to represent the joins, or is it stored somewhere? Or is it like, what's the app like after you get the output? How is it stored? Or I mean,
say it again.
The similarities is a table, like we're talking about a database table now, not the square representation.
Yeah, right? More or less. Yeah, more or less. You don't necessarily need the square representation. So I'm going to share my screen, my browser again. So I would say this similarity here could be represented as a three-column table. So you have the score as the second column, and the first column could be the item 1, and the second column could be item 2. Does that make sense?
Yeah, so you just have a 2-column table, and one column is the first item in the join, and the second column is the second item in the join. And then each entry represents a join of 2 items.
Exactly. So, yes, great, cool, awesome. I think this is it regarding the tutorial. I also have to catch my train now because it's quite late. I don't want to have the Scrum later than 6 p.m. So was that helpful for you, Matt? How to start with a test first and how to kind of,
yes, thank you. Learned a little bit about similarity too, so that's good.
Yeah,
generating similarity tables.
And this is what we just discussed about is a very common task in business applications. Like wherever you have recommendations, you will have probably collaborative filtering, and it's a very well-researched field. And yes, and it's a nice thing to develop. I'm not sure who's going to do it because it's a tough thing, but if I would start to tackle this task, I would do just like that. Start the test first, and then create one model and the association one by one. And maybe as a last thing, you definitely should look for bidirectional loop associations. So I'll put that as a keyword into our Slack channel.
Okay.
Right? Okay. I would say let's call it a day. Oh. What do you think, Matt?
I mean, I think that was a great start. Just give people some time to let it to think over it, and maybe have a follow-up later.
Yeah. I will later on probably share the video, and maybe I hope that Lilibet and Tomasz can get something out of it. And if they have any further question, you are more than welcome to send me a message.
Yeah,
and
everyone's background knowledge will be a little bit different, so stuff. I think it's worthwhile just let them see it and think about it and field some questions. And
yes, exactly. Cool.
Okay. Have a good night. Thank you.
Yes. Same to you. Bye-bye.
Bye.